Hi, and welcome back to another AnyRPG Development Livestream. In these videos, you can watch the live development of the AnyRPG Engine, a free and open source role-playing game engine designed in Unity and written in C#. If you don't already have a copy of AnyRPG, you can pick one up from anyrpg.org/downloads in both Unity package and source code format. You can also find A Lost Soul, the free playable game that I work on in these episodes, available for download at the same page. In this episode, I want to do a short follow-up to the Invector controller support that I was adding recently. I actually discovered a bug in the actual Invector code itself as part of my testing, and I want to demonstrate that bug and then just talk about a really cool technique that I used to sort of solve it or get around it that takes advantage of both reflection and C# dynamic methods. So let's just load up the game here, and I'll do a quick demonstration of the effect of the bug. So if I load up a game and I'm using the Invector controller and the Invector camera, and the very first time I load it up, everything is fine. The camera works, my character can run around. But if I were to delete my character, like say for example I swap characters in the middle of the game or something and not delete the camera, then the next time that I load up a level, I'm going to end up with a situation like this, where my character is way over there, but my camera is sitting over here. And at first I thought maybe there was actually a bug with the AnyRPG code. And I spent about 5 hours writing debug messages in the Invector code and actually found this beautiful little gem right here. So if we, let's actually just quickly look at some debug messages so I can actually show what the issue is. So basically, when our character spawns here, the Invector controller calls a character init, and basically we get a fixed update method and then we get a late update method. And if the code is called in that order, everything works. But when we zone in between levels and we load up not as part of an initial level load but after a cutscene, then our character init runs and our late update runs without a fixed update, because this code is actually running at the end of an update loop rather than the beginning of an update loop. And this means that actually the Invector controller is actually basically vulnerable to a timing bug. And the issue basically is that we can set a target, and if we run it during this camera update states, which runs like basically during the late update method, then you can see in the shooter melee input, we also run this init method, which is what actually makes the camera basically move to your character. Setting the target doesn't do it. But if we run it as part of character init here, then we're not calling the init method after the set main target. So they've actually already basically fixed this bug in their shooter template, but the bug still exists in the v third person input script. And there's actually a way that we can fix this that is very, very cool. And so what we're going to do is, knowing that the only thing that has to happen in order for this to get fixed is that the init method needs to be called, we are going to subscribe to the on fixed update method, which the v third person input actually emits here. So we've got this on fixed update method. We're actually going to subscribe to this and we're going to call init ourselves manually. And we're going to do this using entirely dynamic events in C# and reflection. So let me just demonstrate the code that I found for that. There's a really good article here that I'm going to link, and it's by Microsoft. It's the dynamic method.create delegate method, and this one actually shows you how to create a dynamic method in your code defined at runtime and then emit this method to an instance of an object, which is what we need to do. So what we're going to do is we're going to subscribe to the fixed update, create a dynamic method, send back some strings and some other information in the middle of the dynamic method, and then actually respond to that event. So the code that does this is in the object message controller, and I just want to demonstrate it because I couldn't find like a sample of the exact code that I needed on the web. Even the one that Microsoft used wasn't exactly. So essentially, here is the code that runs this. And what we're going to do is we're going to use the type .getType to basically get a script name right here. And the script name in this case is going to be the v third person input. And then we are going to get some references to a delegate and create a parameter array. Then we're going to use this ilgen dynamic generator to generate a dynamic method. And the reason we need to generate a dynamic method is because when we're subscribing to the onFixedUpdate event, this onFixedUpdate event doesn't actually send any data back. You'll notice it has nothing in the parameter list there. So what this means is that when we're subscribing, if we say, oh yeah, we'll just subscribe some event handler to it, we actually don't know whether we subscribe to onFixedUpdate or onLateUpdate or onAnimatorMove or onUpdate, because we don't actually have any of the invector methods hard-coded in our code here. So what we actually need to do is we actually need to send a string back to ourselves when we get this, and we can actually do this using this dynamic method code right here. So the very first thing that we do in this dynamic method code is we emit an opcodes LDArg0. And this is actually some really interesting magic right here. What it does is when we subscribe to the event, we send in the object instance, and when we put this parameter in, we actually receive the object instance back, which is great because then we can get this object message controller's event subscriptions. Then we're actually going to just emit a hard-coded string, which is the event name. And then we're going to call process local event and pass that information back to an actual static, well, not static, but basically instance method rather than a dynamic method, and then continue processing it there. And you can see here in process local event, we don't receive that first parameter, the instance. You can see here we added that first parameter LDArg0, but we actually don't receive it. And that's because C# at a low level is actually taking that parameter away and then adding it as basically this and making it available internally. So we receive that hard-coded string back, and this is really cool because onFixedUpdate emits no parameters, yet because we can just sort of intercept it and subscribe to it with this dynamic delegate we create and this hard code the string in there, then we can actually send ourselves a string letting us know which event sent us the message, and then we can continue on and we can process it. Now for the processing event, we're going to do something else really cool that we haven't done before, and we're actually going to invoke the init method on a field on this script. So basically we've got a field on this script here, and it's called TP_camera. And we can't just invoke a method on the v third person input script. We actually have to grab this TP_camera field and then invoke the init method on the TP_camera field. So I'm going to show the code that is going to be doing that. So we'll go back into the object message controller here, and we'll look at process invoke responses, which is down here. And we're going to go through the invoke responses basically. We are going to get a type based on a script name, and then we are going to find a field or not, and then find a method, and then we are going to put together a list of parameters based on whether or not we receive parameters for this event or whether or not we hard-coded them. And then finally, at the end of all that setup, we're basically going to grab the method and we're just going to call invoke on it, either sending no parameters if there's no parameters or a parameter list of objects if there are parameters. So let's go back into the game now, and I'll show you what this is all going to look like in the scriptable object. So here we are in the scriptable object. I'm going to subscribe to a local event. We now have a system event list and a local event list on our event message controller here. So instead of us subscribing to system event manager events that our service is emitting, we're going to have this thing actually subscribe to events that the Invector controller is emitting and do something about that. So what we want to do is we want to subscribe to an event on the Invector dot. There we go. Try that again. Sorry. We want to subscribe to an event on the Invector.v character controller. That's the namespace .v third person input. So on the mono behavior that this thing is attached to, we're going to look for this script in this namespace, and the namespace is really important. And then we are going to subscribe to the onFixedUpdate event that this script emits. We're going to set the subscribe stage to start, and that's because we actually need to let it do some initialization that it does in Awake before we actually subscribe to this, otherwise we'll have issues. So you can subscribe to events in now the Awake stage or the start stage. The next thing we're going to do is we're going to send an invoke response. So we now have 4 types of responses. We can either send a message using Unity's send message feature. We can adjust property values. We can enable or disable components, and then we can invoke things a little more flexibly than we can with Unity's send message, because we can actually look up properties on objects to perform these invokes. So what we're going to do is we are receiving an event from the third person input, and then we're actually going to invoke something on the third person input. So we need to have the script name twice, because one is the listener and then one is the action that we're going to be taking. What we want to do is we want to take the TP camera and we want to call its init method, and just keeping this as none type, which basically means it will not send any parameters. It's just going to be init, pretty much like that. And that's pretty much it. So now, using this whole reflection and dynamic event setup, we can actually subscribe to this thing and have it call the init method for us. I'm going to set a response limit of 1. And basically the reason I'm doing this is because we only need to call this init code once. After we call this init code once, then the problem will be fixed. The camera will snap to the character and we won't need to call it again. So there's no point keeping this event listener around and letting the Invector code emit an event every frame or every fixed update, basically, which is actually several times per frame. So what'll happen here is after the response limit is reached, the event will just go ahead and unsubscribe itself. So let's try this out. I'm just going to save that and I'm going to press play. Hey, the skeptic eye. That's a great question. I actually personally don't use any brainstorming software. I actually kind of use Unity as my brainstorming software. And it looks like I actually wrote something wrong here. This isn't supposed to be v third person init, it's supposed to be v third person input. Try that. Helps if we have actually the right scripts. But yeah, I like to actually sort of design my ideas in Unity and just see how they look. But yeah, I've got a lot of ideas and it would be cool to have something good to organize them for sure. Okay, we're going to save that. We're going to press play. And now we should actually hopefully see our method run and our camera actually work when we load between levels. So let's load up our character here. And the camera works the first time. We're going to go zone into a level and escape from the cutscene, and now the camera is actually properly snapped to the character. And if we look back in our code here, we're going to see a bunch of debug messages basically telling us that we are responding to the event on fixed update, and then just a bunch of stuff here happening to let me know that we're actually properly emitting to the TP camera field, and we're going to be sending the init event, and then you can see init properly being called here. So that basically completes the object message template and the object message controller classes, because now we can not only respond to system events, but we can hook into local events and then basically send responses back and do anything to the local code that we want, which actually gives us, this ability to like dynamically fix bugs in other people's code using nothing more than C# event responses. So I hope you enjoyed that. I'm going to put a link for this dynamic method here code, because it was really hard to actually find this one example that did exactly what I wanted. Yeah, so I'll be back soon. I'll be able to continue the testing now that I fixed that bug, and hopefully we'll get Chapter 2 and 0.8 alpha released pretty soon. So thank you so much for tuning in. If you enjoyed that video, then don't forget to thumbs up, subscribe to AnyRPG, or just leave a note in the comments, and I will see you next time.